The origin of planet Earth. Accretion, definition and theory. So, accretion happens when gravity attracts tiny bits of matter towards an object. This results in a gradual increase in the object's size in relation to the solar system's formation. The objects increase in size until they turned into planets. As the objects grew bigger, they pulled more fragments of matter due to a stronger gravitational pull.
We have here the first step to occur a clump of dust grains. So this isolated clump of dust grains, wala pa ni sila nag-join with the other clumps and they measure with at least in centimeter size. So that means gagmay lang ni siya nga mga abog-abog sa atong solar system. Now, since each of this clump of dust grains or kani silang mga dust grains kining matag isa sa ilaha, na sila ginatawag nga gravity nga atong malocate on its atom, so that means it is capable of attracting one specific particle. Now, as this clump of dust grains collide with other dust grains, they tend to stick together or they tend to join together. Now, when this clump of dust grains join together in large numbers, they form planetesimal.
Sa planetesimal, they are of course mainly composed of these dust grains, but of course in largest amount. So planetesimal usually measures in kilometers. Therefore, dagko na ni siya. So compared ganina, ang measurement sa clump of dust grains, ang measurement was just in centimeter. So that means the core of these planetesimal objects exerts a massive gravitational force which is capable of attracting other objects on its surroundings.
Now, this explain this third step. So, kining planetesimal, capable naman siya nga ma-exert og kusog or capable naman siya mo-attract og other materials on its surrounding because it has now a massive amount of gravitational energy. Then, maka-attract na siya og other objects or other pound na mga dust grains on its surrounding. So when this planetesimal forms bigger sizes, which are beyond the usual sizes of planetesimal, then they are now called protoplanets. Now, a protoplanet is usually measured with at least 100 to 1,000 kilometer. So that means it is really big or massive compared to planetesimal because before mo form si protoplanet, planetesimal exists kay siya man ang mo-attract og other pa na mga particles on its surrounding which lead to formation of protoplanet.
Homogeneous accretion hypothesis. The homogeneous accretion hypothesis states that the formation of Earth began after the condensation of fine particles of the primitive nebula about 4.6 billion years ago. When these particles accreted, they formed the homogeneous primordial Earth. Thus, early Earth had a uniform solid composition of its primary components were iron, magnesium, nickel, silicates, and some radioactive elements, such as uranium and thorium. Due to the gravitational contraction and decay of radioactive elements, the temperature of early Earth increased. Iron and nickel melted and they sank towards the center because of their high density. On the other hand, less dense silicate were displaced and moved upwards.
Homogeneous accretion. It is when Earth accreted from materials of the same composition after condensation. Now, what does it mean? It is believed that in the homogeneous accretion, the formation of the Earth began after the condensation of the fine particles of the primitive nebula about 4.6 billion years ago.
So when these particles collide and stick together, they form a homogeneous primordial Earth. Thus, the early Earth had a uniform solid particles or solid composition, and its primary components are iron, magnesium, nickel, silicates, and some radioactive elements, such as uranium and thorium. So due to the gravitational contraction and decay of the radioactive elements, the temperature of the Earth increased. So that's on the homogeneous accretion. Those elements with higher density, they sank toward the center of the Earth. because of its high density. So katong mga less dense nga mga silicates or less dense nga mga elements, they were displaced and they move forward. So in this diagram, we show here the process on how homogeneous accretion leads to the formation of the Earth.
So, the first one. It is believed that similar elements attach to each other, forming a solid mass. So from the image itself, makaingon jud ta nga similar materials ni sila. Okay, from the color and from its size. So, kini daw sila ng mga similar elements nag-attach together or they bond together, nag-stick sila which eventually forms into a solid mass. So, naay solid particles nga na-formed. Now, the second one, particles were melted due to the heat produced in the process, and because of the heat and the pressure that is exerted with the atoms or with the nucleus on each of the elements, then some of those elements melted kay dili naman niya makaya ang pressure o ang kainit nga gina-exert sa iya, especially kung iyang nearby surrounding naga-exert pod og force og heat padulong sa center.
Now on the third one, heavier elements descend to the center due to gravity forming the solid core of the Earth. So because of gravity, so diba si gravity did tend to attract those materials nga kanang makaya ra po niya og attract. So therefore makaingon jud ta nga on the center of a certain materials that exerts too much gravitational force is usually a solid mass. And this explains why the core of the Earth has a solid mass while the mantle are usually in liquefied form. Kay ang mga less dense materials man daw, di daw niya makaya ang pressure o ang kainit nga gina-exert sa core sa Earth. So they displace and they move upward, and that explains why the core of the Earth has a solid composition while its mantle are in the aqueous or in a liquefied form, while on the Earth's crust since it is just an insulation. So maupod ni siya ang reason nganong solid pud ni siya, so dili siya desirable for a certain living things to exist, so it needs to have this solid crust para maka-exist pod ang living things. So always remember nga basta homogeneous accretion, same materials ang ginagamit para ma-form ang Earth.
Heterogeneous accretion hypothesis. The heterogeneous accretion hypothesis states that the core has formed at the same time as Earth. Therefore, early Earth had its basic layered structure with a core, mantle, and crust. According to this theory, as the nebula cooled down, its particles condensed depending on their condensation points. Oxides of aluminum and calcium condensed first, followed by iron and nickel. When the nebula cooled further, the silicates condensed. The condensed particles collided with each other and accreted. The formed particles during the initial stage of condensation accreted first. Following this, aluminum and calcium oxides accreted first, then followed by iron and nickel to form Earth's core. The outermost layer is composed of silicates as well as volatile particles including water.
Heteroaccretion. It is when the Earth accreted during condensation, forming a differentiated planet as it grew. Now, the first picture explained that the particles of matter attached to the center. The metal particles was the first matter joined, and it has solid mass. After solid mass formed, other particle or lighter elements attach its core. Bali, ang pinakabugat nga particle or solid elements mauto ang nag-collide sa center, and the lighter elements mauto sa daplin kay dili kaya sa lighter elements mag-collide apil sa solid elements sa core. And there are similarities between homo and heteroaccretion, but heteroaccretion emphasizes that the solid mass ang pinaka bugat maura ang nasettle down sa core, and after it cooled down, the lighter matter attached next to it. That's the reason why na-form si mantle and crust, the solid and the lighter elements, and other. The heteroqualitative explains the density differences among terrestrial planets.